Good evening, and welcome to Sleepy Space Science. Tonight, we'll travel to a place so quiet, so vast, and so ancient that even light takes years to cross it. A place where stars, the glowing hearts of galaxies, are born. If you're listening right now, you might be lying down, the room dim and still. Maybe you can hear the faint hum of a fan, or the soft rhythm of your own breathing. Wherever you are, this moment is your invitation to slow down, to let the day settle behind you, and to step gently into the calm expanse of the cosmos. Take a deep breath in and let it go. Feel yourself growing lighter with every exhale, as if gravity itself has loosened its hold. Your body rests here on Earth, but your mind, your curiosity, is free to wander among the stars. Imagine yourself floating high above the world. Below you, the lights of cities fade into darkness. Clouds become pale silver sheets under moonlight. And then, even Earth begins to shrink away, until it's just a small blue sphere suspended in blackness. Ahead, there is nothing but open space. But far in the distance, a faint glow begins to appear like a slow sunrise across infinity. As you drift closer, that glow reveals itself as a nebula, a vast cloud of gas and dust, delicate and colorful, suspended in the stillness between stars. This is where every sun begins its life, not in fire or explosion, but in stillness. Here, in the deep silence of interstellar space, the raw material of creation gathers: hydrogen, helium, tiny grains of dust, the same ingredients that once built our own sun. The nebula may stretch for hundreds of light years, yet within it, the air is so thin that you could pass through it without feeling a thing. It's almost empty, and yet, within that emptiness, gravity is working quietly, pulling atoms together, forming invisible knots of density that will one day ignite into light. These are the stellar nurseries of the universe. And tonight, as you rest, we'll journey into one of them. We'll watch slowly and calmly as darkness folds into brightness, as cold clouds gather, collapse, and awaken into new suns. It's a process that takes millions of years, but we will experience it here together in just one peaceful night. So settle in, let your mind drift like dust inside a nebula. Let your breathing slow to the rhythm of the stars. The universe is patient. It has waited billions of years to share this story with you. And tonight it begins. Inside the nebula, there is no sound. The air is too thin for vibration. No wind, no echo, only stillness. But within that silence, things are slowly changing. Tiny atoms of hydrogen, the most common element in the universe, drift and collide. Over millions of years, some regions of the cloud grow just a little denser than others. It's a small difference, almost invisible. But in space, small differences can grow into something vast. Here, gravity begins to take notice. It pulls more matter toward these slightly heavier regions. Every atom that falls inward strengthens the pull for the next one. This gentle gathering continues for centuries, then millennia, then millions of years. Imagine floating nearby, watching this happen. You wouldn't see sudden movement or flashes of light. You'd see nothing, only faint currents of gas, swirling in slow motion, like mist in an endless dream. If you could speed up time, though, you would watch the cloud tighten and twist. It begins to separate into fragments, smaller pockets that collapse independently, each one destined to become a new star. This process, known as gravitational collapse, is how every sun, including our own, began its life. As the cloud collapses, it starts to spin. It's a law of physics that when something shrinks, its rotation speeds up, just like a figure skater pulling in their arms. This spin flattens the collapsing gas into a shape we call a protoplanetary disk, a thin, circular sheet with a dense center. At that center, the pressure builds. Temperatures rise from a few degrees above absolute zero to thousands of degrees. The gas begins to glow faintly in infrared light, invisible to our eyes, but bright to the instruments of telescopes. That glowing center is the protostar, a young, forming sun hidden inside its dusty cocoon. It's not yet shining by nuclear fusion, but it's alive in a quieter way. Its heat and gravity are shaping the space around it. The disk that surrounds the protostar continues to feed it. Streams of gas spiral inward, adding mass to the growing star. With each turn, the core compresses tighter, heating more with every heartbeat of gravity. At the same time, the outer parts of the disk begin their own story. Tiny particles of dust collide and stick together. They form pebbles, then rocks, then larger clumps, the earliest seeds of planets. Even before the star is fully awake, its future worlds are already taking shape around it. From afar, the nebula now glows faintly. Nearby stars illuminate its surface, turning dark clouds into waves of color: pink, blue, green, and gold. If you looked at it through a telescope, you'd see something that looks alive: pillars of gas, glowing edges, and dark shadows that hide new stars within them. These structures, the pillars of creation in the Eagle Nebula, the filaments of Orion, are not static. They are slowly moving, reshaping, and breathing with the energy of their stars. What looks eternal to us is, in truth, changing every moment on a timescale far beyond human life. In these quiet, invisible corners of space, the universe is at work, not rushing, not forcing, simply following its natural rhythm. Every star that has ever shone, every sun that will ever rise, began with this same slow gathering of dust and time. At the center of the disk, the growing protostar continues to tighten. Every bit of matter that falls inward releases energy, and that energy has nowhere to go but into heat. The temperature climbs into the millions of degrees. The pressure becomes immense, so great that atoms are forced closer together than they ever were before. The star is not yet shining the way our sun does. Its light, for now, is the glow of compression, heat radiating from the struggle between gravity and resistance. If you could watch through the dust, you would see a deep orange ember hidden in the gray swirl of gas. It pulses faintly, brightening and dimming as material falls in bursts. The space around it is busy. Streams of gas continue to spiral inward, while other jets shoot outward along magnetic lines from the poles. These bipolar outflows carve narrow channels through the surrounding nebula, clearing pathways through the dust. To the instruments of modern telescopes, they appear as thin blue beams stretching across light years. Signs that a young star is beginning to shape its environment. Slowly, the balance shifts. As heat builds, the inward collapse slows. The outward pressure from the hot gas begins to hold gravity in check. For the first time, the core of the protostar finds temporary peace, a fragile equilibrium. Inside that core, the temperature reaches about 10 million degrees Celsius. At that point, the hydrogen atoms begin to merge. It's a quiet reaction, but its effect is profound. Each fusion releases a burst of energy, small on its own, but multiplied billions of times a second. This is the beginning of nuclear fusion, the engine that will power the star for billions of years. The light produced inside the core struggles upward through the dense layers of gas. It may take thousands of years for a single photon to reach the surface. When it finally escapes, it emerges as visible light, the star's first true illumination. The moment this happens, everything changes. The stellar winds grow stronger, pushing away the remaining dust that hides the star. A new sun appears, glowing steadily in the heart of the nebula. The surrounding gas, now exposed to intense radiation, begins to shine in return, glowing red from hydrogen, blue from oxygen, and faint green from sulfur. From our distant viewpoint, we would see a patch of the nebula brighten. A new point of light has joined the sky, a young star, perhaps only a few 100,000 years old, yet already shining with the calm persistence that will last for billions. Around it, the protoplanetary disk still spins. Within that thin band of dust and gas, particles continue to collide and merge. Over time, they will grow into worlds, rocky planets, icy moons, and gas giants, each following its own path around this newly awakened sun. The nebula that once hid the star will eventually fade. The gas will disperse into space, leaving behind only the star and its orbiting companions. What was once a dim, cold cloud has become a miniature solar system, a bright, self-contained island of warmth in the great darkness of the galaxy. Across the nebula, the same process repeats again and again. Gravity does not act in isolation. Where one star forms, many others soon follow. Entire regions of the cloud begin to glow. As clusters of young suns come to life almost at once, each star is at a different stage of awakening. Some are still hidden, wrapped in thick blankets of dust. Others have cleared their surroundings, their light shining freely into the open void. Together, they form what astronomers call a stellar cluster, a family of stars, all born from the same cloud, sharing the same chemical signature and often the same gentle beginning. From far away, a stellar cluster looks like a jewel box. Hundreds of tiny points of light scattered across a faint haze of color. The famous Orion Nebula, for instance, contains a cluster known as the trapezium, where 4 young stars burn so brightly that they illuminate the entire region around them. Their combined radiation pushes outward, sculpting the gas into vast walls and arches, leaving behind structures that appear carved by hand. The birth of a cluster is noisy, at least in the language of physics. Winds from massive young stars blow at hundreds of kilometers per second. Jets shoot into the void, and shock waves ripple through the gas. But from our distant vantage point, perhaps thousands of light years away, it all appears perfectly calm. The chaos of creation becomes a scene of breathtaking stillness. Each newborn star contributes to the transformation of the nebula. The more massive ones, shining blue-white and hot, send strong ultraviolet radiation into space. That energy excites the hydrogen gas around them, causing it to glow in deep crimson and magenta hues. Smaller, cooler stars emit softer yellow or orange light, creating subtle variations in the nebular color. Together, this mixture of light gives every nebula its unique appearance, a kind of cosmic fingerprint. No two are alike, yet each tells the same story of dust becoming energy and silence becoming illumination. As the cluster matures, its stars begin to drift apart. The gravitational bond that once held them weakly together gradually weakens as they interact with the larger galaxy. After a few 100 million years, most of these stars will have gone their separate ways. Some may become part of new constellations. Others may wander alone for the rest of their existence. Even our own sun, scientists believe, was once part of such a cluster, born alongside hundreds of siblings in a long-vanished cloud. We may never know exactly which stars were our sun's original companions, but their chemical makeup suggests a shared ancestry, long scattered across the Milky Way. So when we look at the night sky, it's possible that a few of those distant, faint suns are our long-lost relatives, stars that once shared the same cradle, now separated by thousands of light years, still glowing quietly in the dark. As the light of the cluster grows, the nebula itself begins to fade. The intense radiation from the stars blows away the remaining gas and dust, revealing the stars in full clarity. In time, the cloud that gave them birth will be gone, its material dispersed across the galaxy, but its work complete. The cluster remains, shining where darkness once was. The cycle of creation has reached its luminous peak. From emptiness, light has emerged. From cold dust, a family of suns now burns across the sky. The stars born inside a nebula do not all live the same kind of life. Some burn hot and bright, using their fuel quickly and ending in spectacular explosions. Others, smaller and cooler, burn slowly and steadily, glowing for billions of years. The difference lies in mass, how much material each star gathered during its formation. The more massive a star is, the stronger its gravity, the faster its core compresses, and the hotter its nuclear furnace burns. But that brilliance comes at a cost. A massive star can shine 1,000,000 times brighter than our sun, yet live only a few million years, a brief spark in cosmic time. Smaller stars, like our own sun, live much longer lives. They burn quietly, converting hydrogen to helium at a steady pace. For billions of years, they remain stable, balanced between the inward pull of gravity and the outward pressure from their energy. It's a perfect equilibrium, one that allows planets to form and life to evolve around them. If you could fast forward time, you'd see the nebula's young cluster gradually change. The massive blue stars, brilliant but short-lived, begin to fade first. They swell into red supergiants, their outer layers expanding far into space. Then, when their fuel finally runs out, gravity takes over again, this time collapsing the core with incredible force. The stars born inside a nebula do not all live the same kind of life. Some burn hot and bright, using their fuel quickly and ending in spectacular explosions. Others, smaller and cooler, burn slowly and steadily, glowing for billions of years. The difference lies in mass, how much material each star gathered during its formation. The more massive a star is, the stronger its gravity, the faster its core compresses, and the hotter its nuclear furnace burns. But that brilliance comes at a cost. A massive star can shine 1,000,000 times brighter than our sun, yet live only a few million years, a brief spark in cosmic time. Smaller stars, like our own sun, live much longer lives. They burn quietly, converting hydrogen to helium at a steady pace. For billions of years, they remain stable, balanced between the inward pull of gravity and the outward pressure from their energy. It's a perfect equilibrium, one that allows planets to form and life to evolve around them. If you could fast forward time, you'd see the nebula's young cluster gradually change. The massive blue stars, brilliant but short-lived, begin to fade first. They swell into red supergiants, their outer layers expanding far into space. Then, when their fuel finally runs out, gravity takes over again, this time collapsing the core with incredible force. Every star, no matter how long or short its life, plays a part in the same cosmic rhythm: birth, life, death, and renewal. Each generation of stars enriches the galaxy, seeding it with new elements, new potential, and new light. Our sun, too, came from such a cloud, one that lived and vanished billions of years ago, long before Earth existed, before oceans or air or life. A supernova scattered its ashes into space. From that dust, our solar system was formed, and from that same material came you, listening now beneath your quiet sky. It's humbling to realize that we are built from the remains of ancient stars. The calcium in your bones, the iron in your blood, the oxygen in your lungs. All were once part of a star that lived, shone, and died long before the sun was born. You are not separate from the cosmos. You are one small expression of it, a way for the universe to look back and wonder about itself. When you gaze at the night sky, you're not looking into the past. You're looking into memory, the story of your own beginnings, written in light. Each photon that reaches your eyes has traveled for thousands, sometimes millions of years, crossing the emptiness to tell you, this is where you come from. The cycle continues even now. In distant regions of the Milky Way, new nebulae are forming, quiet clouds gathering under gravity's patient pull. Within them, atoms begin to meet, spin, and compress, repeating the same slow dance that has shaped the universe for 13 billion years. One day, long after our sun fades, the atoms that once made up our world will drift back into space. They will join other clouds, and in time, those clouds will give birth to new stars, new planets, and perhaps new forms of life. It's not an ending, but a continuation. The universe breathing, expanding, and creating, over and over again. The same light that once illuminated the birth of a star now rests within you, faint but constant. It is the warmth in your skin, the spark in your thoughts, the quiet awareness that allows you to feel wonder. That too is starlight, slowed, softened, and alive. So tonight, as you close your eyes, imagine that gentle light surrounding you. You are floating again within a nebula, calm, weightless, at peace. The stars around you shimmer like distant dreams, waiting to be born. The air is silent. The universe is still. Take one slow breath in and one long breath out. You have traveled from dust to light, and now back to dust again, not in sadness, but in harmony with the rhythm of all things. The cosmos has been creating and recreating for billions of years. It will continue long after our time, weaving the same quiet story of light becoming matter, and matter becoming light once more. And now, under that same vast sky, your part in this story is simple: to rest, to let the endless cycle carry you gently into sleep. Good night, traveler of the stars. May your dreams drift among the nebulae, and may the same light that built the universe shine softly within you.